Oh, man.
Class act. Hello.
Yes.
Um,
I know that
is
the quiz will be available in just a second. Hang
sure.
on here. Sorry, Moodle's running slow. Great. Come on, stupid. Okay. Okay, there we go. Should be allowed in there now.
This is I just want to represent the distinctly identified entity.
Professor, could you check the chat?
Huh? Don't know that you'll need co-host today, but I will give it.
Listen,
Yeah.
If you don't submit the quiz, but we have answered all the questions, do our answers still get recorded?
So if you run out of time,
Yeah, but you have still answered all the questions, just didn't submit the.
yeah, I think it does.
Okay, thanks.
Okay. So I know a few people are finishing up, but welcome to class. Thank you for coming. Hope you guys are all doing well. So today we're not doing a POJA, but what we're going to do today is we're going to finish talking a little bit more about classes, do some examples, and then we're going to talk about the blackjack assignment. And so let me start by talking a little bit about the POJL that we were talking about. And what I'm going to do is let me bring up, I'll find it. Let me bring up the code that we looked at. Now, let's look at model 2. And again, to recall what we were talking about, we're talking about classes, and classes have member functions. And so what I'm going to do is here is this link called classes works, and that goes here, and I invite you to look at that and kind of follow along with me. We're going to talk about classes. Python provides support for object-oriented programming, including the ability to define new types or classes, which we saw in the POJL on classes. It's not easy to provide a crisp definition of object-oriented programming, but we've already seen some of the characteristics, right? Programs are made up of object definitions and function definitions, and most of the computation is expressed in terms of operations on the objects that we create. So we create an object.
Sorry, Professor, we cannot see your screen.
Oh, okay. So I forgot to do that. So here's what we're looking at here. So this again is this web page that's pointed to classes work on November 12th. And so programs are made out of objects, and objects contain information, and they allow us to do things on those objects. So for example, we can have an atom object, and we can have a carbon atom and an oxygen atom, and then we can do things with those objects. So we have these classes, and we make objects out of them, and the objects represent something in the real world. So each object represents some object or concepts in the real world, and the functions that operate on that object correspond to the ways real world objects interact. Now, so I have some terminology here, and what I'm going to do is I'm going to jump over to the slides that we had last time. And if we go to the end on slide 35, let's look at this slide for a moment. And what we see here, this sort of gives us an idea of how all these pieces are put together. An atom is a concept, right? There is no thing that is just an atom, right? An atom is a concept, and then we have types of atoms. And so we have an oxygen atom, and we have a carbon atom. And so an atom is a class of things. An oxygen and a carbon is an instance of an atom. That's what we call these things, instances of atoms. When we take and we make an actual atom, we call it an instance. We also call it an object, right? So an instance of a class is an object. So oxygen is an object, carbon is an object, and these items are of the class atom. Now, inside of objects, we have some things. Two of the things that we saw before is we have variables inside of inside of objects. And so whenever we're talking about our own variables, there are our own variables. So carbon's mass versus oxygen's mass, to talk about our own values within an object, we use the prefix self to say, this is my mass. Carbon says, this is my mass. Oxygen says, this is my mass. So these we call instance variables. They're variables in the object, right? Every time we create a new object, every time we create a new instance of an atom, we create all the variables that go along with it. So an object is a collection of the variables. In fact, we could have, in the case of the atom, we have lots of variables. We have lots of instance variables inside of each atom, the mass, the symbol, the atomic, and the isotope. Now, another thing that we have associated with every object is methods. Now, all objects within the same class, i.e. all atoms, have the same set of methods, and we can call those methods. So we have a neutrons method, and we show it, and it works in any of the atoms, including the oxygen and the carbon atom. Now, outside of the program, I can create an object, I can create an atom. Oxygen equals atom, that creates an atom called oxygen. And that creates an instance. We call that constructing. We're constructing. And so when we say atom parentheses, of course, we're calling the constructor. We saw that last time when we saw the init. The init is a constructor, and that gets called when we create an object. And so here we're creating an object. And then if we want to get to things that are in the object, we can just use the name of the object as a prefix. And when I say object.mass, that's getting to self.mass inside of oxygen. Mass, carbon.mass is getting to the carbon's mass. And of course, I can call oxygen.neutrons, I can call the neutrons function on oxygen. So we have this idea of encapsulation. An object is an encapsulation of some variables and some methods. Now, when we're talking about variables, we've seen lots of different types of variables, right? We've seen just regular variables. We've seen global variables that are available everywhere. And we've also seen local variables. Local variables are variables that are created inside of a function, and they only exist in the function. And so in the grams to moles, we created a variable called moles. That is not an instant variable. That's just a local variable. And we'll look at that code just to make sure we remember what we were get rid of that. So in here, notice here we have a constructor for the atom. We pass it a symbol, an atomic, a mass, and an isotope. And we're putting those values inside of this atom. Here in the grams to moles, we have the variable moles. Now notice it doesn't have self in front of it. That's just a local variable that's only has a value while we're in this function, and then that variable ceases to exist. Finally, one of the things we were talking about in Model 3 was this Avogadro's number. Now, notice that that variable doesn't exist inside of the objects. It actually exists inside of the class. It's a shared variable amongst all of the instances of that class. So oxygen, carbon, I could have other ones. They're all going to use the same Avogadro's number, which makes sense because Avogadro's number is a constant across all atoms. And so we can access that from anywhere. We can access that from inside by putting the name of the class as a prefix dot the variable, atoms, Avogadro numbers. Here, outside of the class, we can refer to that. That, again, is called a class variable. Instead of an instance variable, like we saw here, instance variables are variables inside each object, whereas class variables are variables that are shared by all of the objects of that same type, of that same class. Okay. So let's look at an example of this. And sorry, if we go back to here, and again, if we go into classes work, what we're going to do is let's look at employee. Employee is a new class we want to look at. Now let's talk about that class. So employee class, it has this variable, employee count. What type of a variable is that? Is that a local variable, an instance variable, a global variable, a class variable, or something else? Now notice where it's defined. It's defined outside of any of the functions. Now let's look back over here when we were looking at Model 3. We see Model 3, we have a class atom, and then we have Avogadro's number. And notice this, it's outside of the classes. It doesn't have a self in front of it. Therefore, employee count is a class variable. It's a variable that's shared amongst all of the instances of the employee class. Now, an employee is a thing. And what we're doing is we're building a model of that thing. So we have this thing, which is called a constructor. And when we want to create a new employee, we want to give it a name and a salary. And then again, of course, we just have self here. So we have a way of talking about our own variables. And what I do is I take the name parameter and I put it into name.self.name. I take the salary and I put it into self.salary. And then look what I do here. If I want to get to this variable, since it's a class variable, I take the name of the class dot the class variable, and what am I doing to it? Nobody wants to talk. Cameron, what am I doing to this variable? call on people.
You're adding to the count. You're adding one.
Yeah, I'm adding one to the count. Now, since this is a common variable, what I'm actually doing is every time I create a new variable, a new employee, I'm going to add one to the employee count. Doesn't that make sense? I want to keep track of how many employees I have. Then I have a display, which displays, display count, which just prints out the employee count, and display employee, which prints out the employee information. So let's take that code and copy it. And I encourage you to do the same thing. Go into REPL plus employee class example. Better select a language, Python, create REPL. So if I take this, and actually I'm going to take these extra spaces out here. It will work without that, but I don't like the way that looks. Okay, so I have my class. This is a class, it's an employee class. Now how do I make an employee? Well, I define a new variable and I say employee. Now, notice when I make an employee, I have to give it a name and a salary. So I can give it a name. My system just periodically hangs, okay. Bill Yakus. And good old Bill makes $50,000 a year, okay? Now, I should be able, since I've made it, I should be able to do things on Bill. So I should be able to say employee1 dot display employee, and that should print out Bill. Now notice I could, before I make Bill, I could do employee1 dot display count. I haven't made any employees yet, and so let's see what happens. Well, I haven't made an employee yet, so it doesn't make sense. Actually, what I could do here is I could go ahead and print employee dot display count, and let's see what it is. Oh, yeah, okay. I can't do that because I haven't used my employee class yet, so let's forget about that. So I make an employee, I display the employee, and now let's look at the count. Sure enough, here's my employee, and the total employees is 1. Actually, I don't know why I have it just employee. I should have total employees. Now, I can do this again. Let's do this again. Let's make an employee 2 called Lizzie Randolph. And let's say she has a salary of 75,000. And now we can display that employee and display the account again. Notice I have 2 employees. And of course, I can go ahead after this is all done, and I can still wait, what did I do? I don't know why I did that. I meant to do this. So now, so I can print Bill again. So I can make as many employees as I want. In fact, I could do this. I have a 2 here, so I better do 3, 4, 5, and this is going to be Neil, and they're going to have 23,000, and Lester, and they're going to be 60,000, 6,000. Well, Lester doesn't make much, okay. And Kathy, and she makes an even 100,000. So we run this, and notice now, after I've created all 4 of these, I print my Bill Yakis, but then when I display the count, we're up to 4 employees because I created 4 employees. And here, I added 1 more employee, and now we're up to 5 employees. And by the way, once I've used this, I can actually do this, print employee dot employee count, and we see that we have a 5 here at the end. So that's kind of nice. Any questions at this point? So if you've already made your own and you have it working, that's fine. But if not, I'm going to, if you're struggling with this, I'm going to give you a copy of this. Yeah, okay. Oh, actually, hold off on that first. Well, no, let's do that. Okay, so now let's go back to this classes thing. We see that well, this just talks about it. We have employee count, which keeps track of our number of accounts. We have init, which creates new employees. Now, what I want you to do is this. All right, let's go down to here, activity, because I've pretty much shown you all of well, actually, there's one other piece here I want to show you before we do this. So what if I can, at random, anytime I want, let's get rid of all these people. I can do something like this. I could say employee1.age is equal to 54. And here, employee2.age is equal to 43. Now that'll run. Now, of course, it doesn't display it but I have added values. And in fact, what I can do is I can do a print employee1 dot age, and then I could do it again for employee 2, and we should see those 2 ages. Sure enough. So I can add, anytime I want, I can add additional member variables. And so, in fact, I could add a whole bunch of things just for Bill. You know, I could say, you know, Bill has an age of this, employee 1 dot phone is equal to, right, and so on and so forth. All right. Now, let's go ahead and get rid of all that for right now. So what I would like to do next, make sure this all still runs, yes, is I want you to try to add, and then chat me your REPL when you get it done, add a position attribute to the employee, but actually do it in the constructor. So make the init constructor so it has an additional parameter called position, and that position, let's let it default to an intern. So if we don't tell what somebody's position is, they just automatically become an intern. And then let's modify the display employee so that it displays the position. So I want you to try that. I'm going to give you 5 minutes. to basically do 1 through 4 here. And again, I sent you, if you weren't able to get yours going, I sent you this copy of the code. You can work from there. And then I'll play music. This is like a test, you know, I should play the music. Dun, 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 while you're working away. Now you know why I'm not a music major. Oh, actually, I see that I don't think I sent the thing to everybody. I apologize. I sent it, but I sent it to a just session, which is ridiculous. Okay. Anybody got it?
I have it, but it's asking me to fork it. Should I fork it?
Right, right. You should fork it, right. You should all make your own copy of it. Yeah. Fix all my dogs barking because the mailman came.
Where did he send it?
What's that?
Where did you send the code?
I put it in the chat.
Oh, okay. I'm just using what you have on the website. Is that fine?
That's fine. Yeah, that's more what I was expecting you to do, but I also sent this to you just in case somebody was struggling.
Oh, okay, understood. Thank you.
All right, let's talk about it a little bit. So let's see what we would do here. I think you guys are still seeing my screen. What do we want to do? If we want to add position, we want to add a position variable to here. And if we want to give it a default variable value, we can just give it. Remember, we can give default values, but only to ones that are at the end of the list. Then if I have position, I need to put it in myself. So I say self.position is equal to the position that I passed in. Now, the reason we know this is a different position is because it doesn't have self in front of it, right? This position is not the same as this position. This is the position that is the member variable, and this is the position that is the function parameter. Although we call the function a method when it's inside of a class. So here we're passing position in and we're putting it in there. And by the way, it should all still run, but we don't see any difference. And that's, by the way, one of the beauties of classes is you can change the class without necessarily changing the code that uses it. Now what I can do is I can go down to display employee and I can add a little bit of something. I can say, quote, position, colon, comma, and then self.position. Now let's see what happens. Again, I'm not going to change anything else. I'm going to run it. And of course, it's going to be persnickety here. REPL's going slow. See if eventually it'll run. There we go. Now notice, name, Bill Yakis, salary 5,000, position, probably should have put a comma in here. It says intern because I didn't pass it a position, but I set the default to be intern. So if I go into the class, into here, I could make Bill Yakis be a programmer. And I could make Lizzie be a VP, and let's run it. Sure enough, Bill Yakis is a programmer. And Lizzie is a VP. Now let's say Bill Yakis gets promoted to senior programmer. What I could do is I could say employee1 dot position is equal to senior programmer. That's not, it's imp. Okay. And now if I display the employee again, it should show that here programmer, Bill was a programmer, but then after I changed him to a senior programmer. All right, so I can fiddle with these things all I want. So I just added something new to the function. Now, going back to here, let's do something else. Let's try to write a function called raise, and we pass it a percent. And so what I'm saying is if we put in a raise of 0.01, that means we want to give them a 10% raise. If we put in a 1, it would give them a 100% raise, right? So this is a fraction that we're going to pass in. Because we want to be able to give people raises. So that's a new function. So what would we do? Well, actually, before I do this, I'm going to show you something else first. Typically, when I make classes, I don't put the classes in the same place as the code because I like to keep my classes off by themselves. So what I'm going to do is I'm going to click on this add file button, and you should do the same. And I'm going to make a new file called employee. Whoops. And I want to spell it exactly the same way I spelled my class name, and then I'm going to do py. Now that's an empty file, but I'm going to go back to main. I'm going to grab my employee class and I'm going to cut it. I hit Control or Command X, depending on which computer you're on. And then I went over here and I pasted it in. So the idea is now the main just has code that uses the employee. But now, of course, it's broken because it's saying, I don't know about employee. Well, what I can do is I can say from employee, and from says, look for a file, a py file, a py file of this name. Import, we've seen this before, employee. Now it runs just like before. Now notice how clean this is. This is the code that uses the employee. This is the code that defines how employees work. This is what we like to do with classes. Okay? So now, going back to here, let's work on this raise thing. What we're going to want to do, oops, I went to the wrong code here. What I'm going to want to do is go back to employee, and I want to add a new function. Oops. So I can do def. Oh, by the way, I don't call it raise. I ran into this in the last class. Raise is a reserved word in Python, and raise doesn't work. So what I want to call it is give raise. So I'm going to call it give raise. So let's call it give raise, and I'm going to have the raise, the percent be in here. Okay. Now I didn't do it before, but you know, well, let me not say that for right now. Okay, so what do we want to do to give a raise? Well, since that's a percent, what we want to do is take their salary and we want to add something to it. Now, what we can do is we can say self.salary, and it turns out we can say times 1+%, right? Because think about this. What this means is, oh no, what am I getting? Oh, I forgot to put self here. Anytime you make a new function, you got to do self. Okay, so I'm saying take my salary and multiply it by 1 times the percent. So if I said 0.1, that's a 10% raise, I'm going to multiply it by 1.1, which is going to give me a 10% raise. So it's that simple. Now, here's the beauty. Now, notice I changed the employee. I come over here and run this, still works fine. But what I should be able to do now is give my 2 employees, my system stops being frozen, give my 2 employees raises. So let's take employee 1 dot give raise, and we're going to give him a 10% raise. And we're going to take employee 2 dot give raise. We're going to give her a 20% raise, right? See that? And so let's see if this works. Works, but of course we don't see anything different because we're not displaying our employees. So after we're done with this, let's go ahead and do a print to give ourselves a little bit of headroom, and then display employee 1 and display employee 2. So we run this, and notice here we have the original pay, 50,000 and 75,000. After we give them a raise, sure enough, Bill Yakis goes up to 55,000. Now we've got this little fraction here. We should use the format to get rid of that. And Lizzie's pay went from 75 to 90. See how that works? So we can add things to employee, and then we can use them or not use them as we see fit. So an employee encapsulates the representation of things we want to do with an employee, and we then use the employee here. Now going back to the things that we want to do, let's try something a little more adventurous. Let's see if we can give each employee their own unique ID, because typically employees and students and everything, when you all have your own ID numbers. So how might we do that? Well, there's a variety of ways of doing it. One way, I guess we could ask somebody to give the number, but then you'd have to make sure you didn't use a number that was already in there. We could generate a random number, but how do we know we don't get the same random number that we did for somebody else? So what we're going to do instead is we're going to start with an employee number, and then we're just going to add on to it. So let's do this. Let's go back into employee, and in addition to employee count, let's make something called next ID, and let's start our IDs at 1,000, just because that's where we want to start it. And now let's do this. Every time we create a new person, what we're going to do is we're going to say self.id is equal to the next available ID, and then let's take, sorry, I have to say employee, right, because that's a class variable. Oops. Right, and then we can take self.id plus equals, let's say we want to go up by 5, just because we like IDs that aren't sequential. Okay, so now I run this, by the way, and everything runs. Don't see any difference because we need to go ahead and modify our print function to show the IDs. So let's say, quote, ID colon, comma, self.id, comma. Let's see what happens. Again, we didn't change anything in main. We just updated the employee. Haven't changed anything in main. Didn't change anything here. Boom. Now notice Bill Yakis has an ID of 105, 2005. Oh, didn't work. Everybody's 1005. So what did I do wrong here? See, Bill should have had an ID of 1,000. Oh.
Because the starting point is always 1,000, and then you're adding 5 to it.
Right, but we should have given the first one 1,000, and this hasn't worked in the last class. I'm not sure. You see what I'm missing here? I clearly
I think you need to multiply 5 by employment count and then add that to self ID.
No, I shouldn't need to use employee count. I could do that. You're right, but I shouldn't have to do that. Oh, I see what I did. I'm so stupid. It's next ID that I'm supposed to add on to. I am sorry. I just totally confused myself. So it's employee. There's my so stupid problem. So I take the employee's next ID and I put it into this guy's ID, and then I add 5 to the employee's ID. Now it'll work. So now Bill Yakis has 1,000. Lizzie Randolph has 5,000. Bill Yakis still has 1,000. And then here, Bill Yakis is still 1,000 and Lizzie. So we could create a new employee. Let's go down here and make another new employee. Let's make this just be an intern. And so they're only going to make 20,000 a year. And this is employee 3. And this is Bilbo Baggins. Wait, no, Bilbo Baggins. I think that's how, I don't know, is that how you spell his name? I don't remember. Okay, so now we should be able to display employee 3 dot display employee. And let's run it. And so now Bilbo Baggins has an employee ID of 1010, right? And of course, if I display employee count, it actually doesn't matter which employee, they're all going to be the same count, right? Total employees is 3. So now I have more information. I have an ID, I have a name, salary, and position for each employee. So we can see again how I can do stuff over here and not really worry about it over here if I'm careful. And I can do stuff over here and don't have to worry about what's going on over here. This is the whole notion of abstraction, right? I've created an abstraction of an employee where I can use it without necessarily thinking about how it works. Now, let's try to do one other kind of cool thing. And I'm going to try to go fairly quickly on this, but let's write a program that creates a list of employees and then allows us to add employees and delete employees and list employees. So how hard would that be? Well, here's the cool thing, and this is important to understand. We can do this without modifying employee at all. I can get rid of all this code except for that top line. And I can make a main program, which basically says while true, helps if I know how to spell true, and it says it does option equals int input, and I'll print all this stuff out. Okay, so it should add, and then what I'm going to do is, and this kind of shows you a good way to write code, how to break it down into little functions. I can say FO option equal 1, add employee, LF option equal 2. What do we want to do? List employee, LF option equal 3, delete employee, else print what? Oops. Now I've written a little bit of code. Let's see if, now of course it's not going to work because I have to add these functions. So let's add these functions. Def add employee and I'll add my 3 functions as stubs and just test this out to see if it works. Whoops. I think this is locked up again. There we go. Add employee, list employee, delete employee. So this is a really quick little piece of code. And then down here, point, I need to call my main. So main simply does a little loop. Let's run it. Add employee works. If I do 4, it says what? Okay, so it's not doing anything because I don't have anything in here. Now, if I'm going to have employees, I need a list of employees. So up here at the top, let's say employees is equal to an empty list. And then it becomes really easy. All I have to do, if I want to add an employee, let's create an employee. So let's say name is equal to input name Okay. And I can do this for all three values. Salary, position. So I'm going to get these three things. And I can create a new employee. So I can say E is equal to employee name, comma, salary, comma, position. You agree that that's going to create a new employee with a name, salary, and position. And then all I have to do is say employee dot append E. And that's employees, sorry. So let's go ahead and just for the fun, try this. And at the end of the while statement, let's print out employees, just as a test. That's what I usually try to do, is write my code and then test a little bit of it. So let's run it. If I do 1, it says name, bill, salary, 30,000, position, programmer. 1, looks like it's working. Oh, I didn't put this in far enough. 1, whoops, whoa. Look, I have a list, and look, it says there's an employee object in it. Let's add another one. It's not really that useful yet. Cindy, salary 40,000, position VP. Now I have a list with 2 things in it, with 2 objects in it. Of course, that doesn't look very good. Let's get rid of that line, and let's actually get list employees to work. So how do we go through a list? Well, we've done that a million times, right? I can say for E in employees. Now each employee is an employee object. So all I have to do is say E dot. Remember, the employees has a function called display employee. So let's do that. Oops, that's not what I wanted to do. That's all I should have to do. It's so simple. So let's see if this works. So I run this again. And I say 1 add employee, bill, 30,000, programmer. Let's add another employee, Ann. Salary, 60,000. Software engineer. And now if I do list, there it is. We listed both of them out. Let's add another employee. Kathy, salary 100,000. Position VP. Let's list. There it is. We have all 3 employees. And so I could keep adding employees and listing employees. Now look at how easy that code was. I wrote this very simple little program here. I wrote a little routine to add an employee and a little routine to list employees, but they're not that complicated because the employee does most of the work, right? Now, the final thing I wanted to try to do, and I want to do this quickly because I want to get on to the next thing, is how do I do a delete, huh? Well, as you may recall, if I have an array, I mean a list, sorry, and it has stuff in it, Here's A. I can remove something from a list, remember, by doing a del A sub 1. And when I print A, it got rid of the one element, right? So I ought to be able to do that here. But the problem is if I want to delete an employee, I have to figure out which employee I'm going to delete. So why don't we do this? Why don't we call list employees just to show the user a list of all the employees. And then let's say ID is equal to the int. Oh, up here, I'm going to have an error. When I input the salary, I need that to be a float, right? Because that's what salaries are. Forgot to do that. And when I input no, actually that wasn't that big of a deal. I should be fine. So ID is equal to the integer of input select ID, right? In other words, I want them to do the ID of the person they want to delete. Then what I can do is go through the list and find it. Now the thing is I need to know its index. So instead of going through the employees this way, I'm going to go through the employees this way. For I in range employees, whoops, the length of the employees, this will give me a number, this will go through the employees list. And what I can do is I can look for the employee that they entered the ID for. So I can say F employees sub I, right? Because I'm going through the employees. F employee sub I dot ID. I'm going to look at the ID of this of the ith employee. If that's equal to the ID that they just typed in, let's delete it. DEL employees sub I, and then return. Now, I didn't say equal here, so let's try this. So again, what I do is I ask for an ID, I go through the list of employees looking for the matching employee, and when I find the I, the index of the employee that matches, I'm going to remove that employee. So let's see if it works. Add employee 1, Cindy, salary 40,000, position clerk 1, Ralph, salary 20,000, intern 1, Bert, salary 70,000, programmer. Now let's list them. That works. Now when I do 3, it should list the employees and ask for an ID. So if I say 1,000, we broke it. What did I do wrong? List index is on line 22. Well, that's weird. Okay, so this is okay. I'm going to print out my eyes as I go through here and quickly do a debugging. And my system just one. Select ID 1005. Maybe Seemed like it worked that time. It did work. Don't know why it didn't work the other time, but it seems to be working now. Let's try it again one more time. Well, I'll try it again real quick one more time. Bill, salary, position, VP. 1, Cindy, salary, 200,000, president, spelled wrong. I really typed that in fast. Bert, salary, $40,000 clerk. Okay, so we list, we delete, and let's delete Bert, 1010. And we list, and Bert is gone. So notice how we made this really simple little application, which I'm going to give to you. Again, this is it. You can play around with it. And I have the employee, and I use the employee. And that's the whole idea. I create an object that does its own thing, and then I can use it to build something. And I can use lots of objects. In fact, that's what I want to talk about next. The last thing I want to talk about today is the last project. So let's open this up. Blackjack. Now, Blackjack is, I'm going to build Blackjack using objects, and just like before, I've given you a lot of it, and you just have to finish it. Now, Blackjack is a game that, if you don't know it, here you can kind of play it. Here's Philander Chase's Blackjack game that I threw together. And basically the way it works is each person is given, you and the dealer are given 2 hands, and you can see your hands, but you can only see one of the dealers. And then you try to get to 21, but not over. If you get to 21, you win. If you're below 21, but you're higher than the dealer, you win. If you're below 21 and the dealer is higher, he wins, or she wins. And the way we count our cards are, if it's a number card, it's just the number. If it's a face card, that is Jack, King, Queen, it's a 10. If it's an ace, it's either 11 or 1. It's 11 if 11 would help you. It's a 1 if a 1 would help you. Whatever's better for you. So look, we have a 12. We don't know what they have, so we're going to say hit to get another card. And we get a 10 and 1 over, and the dealer won. We busted. So we say again, we got a 16, let's stay. The dealer goes over, and so we won. So we can do a new game. We got a 19, we better stay, right? So we can play this. And under the watchful eye of Philander Chase. I hear that he was quite the blackjack player. I don't even know if that game existed back then. Maybe it did. I don't know the history of blackjack. Okay, so how do we do this? Well, it turns out, and there's lots of stuff here, it turns out I give you a starting point. And the starting point has a main line, which is a shell of a game, but it's not done. Okay, I give you a card class, a deck class, and a hand class. The card class is simply a class that allows us to represent cards. And so when we make a card, here's the constructor for a card. We give it a suit, and we give it a rank, and a value. And the value is between 1 and 11, okay? Now, well, and then there's a card info, and this is all it does is it says the rank, which is like clubs, diamond, I mean, it's the rank, here's the ranks, and here's the suit. So it says the rank of suits. So, for example, you can have the king, queen of diamonds, or the 3 of spades, or the 10 of clubs, right? So when I make, what's kind of cool is when I make a card, what I do is I use these values and I look up the values. So for example, notice that these are class variables. These lists are available across all cards, so I can look them up. So what I do in order to get the value of a card is I look in the card for values, and here's values. And I say, I take the ranks, which is here, card.ranks looks up this array, and I say index rank. Now remember what the index does is it takes the rank of the card and looks for its index and returns that number. And the reason why that is because these numbers are the values for each of these cards. An ace is an 11, a 2 is a 2, a 3 is a 3, and a 4 is a 4. So I can look up the value of the card when I create it. Now, how are these cards created? Well, we'll see that in a second if we look in the deck. Now, a deck uses a card, and a deck has a simple constructor, and what the constructor does is it just builds a deck of all 52 cards. Now, how that works, it uses something called list comprehension that we actually haven't had time to talk about, but this is a neat little trick that goes through the card values, and it basically makes a pair of everything, right? In other words, it makes an ace of clubs, an ace of diamonds, an ace of hearts, an ace of spades, then it makes a 2 of clubs, a 2 of diamonds, and so forth. So this basically creates a list of all 52 cards. Now the problem is, its deck needs to be shuffled. In fact, I have this routine called show deck. All it does is it goes through all of the cards in the deck. Notice the deck is a list of cards. It goes through self.cards and it calls for every C in the list of cards, whoops, it says c.cardinfo and it shows the deck. We're going to see where that gets executed. We don't actually use that in the program, but that's just for diagnostic purposes. And then a draw is how we take something off the deck. What we do is we pop something off the card list and we return it. So that's how we do, that's how a deck works. Now you're going to have to finish this. Notice I haven't written all of it. I've written pretty much all of the card. You don't have to worry about that, but you're going to have to finish the deck. And then here's the hand. The hand is what you're holding, right? And a hand starts out empty, and it has an owner who defaults to the player, but it could also be the dealer. We can add a card to the deck by appending it to our cards list. We can look at the first card, or we can look at all the cards. I didn't write that. So you're going to have to write that. And then there's a tally where you go through and you figure out the tally. Now that's a little bit tricky. I wrote part of it, but you're going to have to look at it and say, hey, if there's an ace, is it better if the ace is an 11 or a 1? So that you're going to have to do. So these three classes go together for the game. Well, how is the game played? Well, it basically, it just starts up. I say C is equal to something because I have to put something in there. And I say, well, C isn't equal to quit, play the game, and then ask if they want to continue. How does the game play? You've got to finish this. But what the game does is the first thing it does is it calls new game. And what new game does is it creates a deck, it shuffles the deck, which doesn't work yet. For diagnostic purposes, I'll write that in there for debugging only. You'll want to take this out. If it's in your program, you'll get a bad grade. Debugging only. Remove. This goes ahead and shows what's in the deck. Then we create a dealer hand and we create a player hand, and I draw a card from the deck and I put it in the dealer's hand. I draw a card from the deck and I put it in the dealer's hand, right? I draw a card from the deck and I put it in the player's hand. See how by using class, how nice this is, right? I can go to the deck is my deck class, and I can draw a card out of it, and I can add it to the dealer's hand, because the deck function has, the deck, not the hand. Where am I at here now? I'm sorry, the hand has an add method. So I call that add method to add a card to the hands of the players. Then this new game function just basically deals the initial cards, and it returns the remaining deck, the dealer hand and the player hand, and then it goes ahead and does the playing. Now this isn't complete, but it does start out. Notice it says prints dealing new cards. It deals the cards, and in the process of it, I show the deck, just to show the deck. Now notice the deck starts out with all the cards in it, and notice that the cards aren't shuffled yet. Ace of clubs, 2 of clubs, 3 of clubs, 4 of clubs, 5 of clubs, 6 of clubs, and so on, right? The cards are all in order. So if I take this out and we play it, we see that it deals the cards, and it starts by showing, the dealer shows, and it shows King of Spades. Because in here, the game comes in here, and first thing it does is it creates a new game, sets stand default, and it says while the dealer is less than 21 and the player is less than 21 and we're not standing, the game plays. So here we print the dealer's first card, because that's what we do, and then we should print the entire player's hand, which doesn't work yet. I haven't written that yet, so it just says the player shows a list of cards. Because when we go into the hand, we see show hand only returns in hand a list of cards, because it's not complete, right? So then I can hit or stand, like I say hit, whoops, I want to do that, hit, and it says you draw a 9 of spades, because if you say hit, it draws another card out of the deck, and it adds that card to the player. And here's the dealer strategy. This dealer strategy keeps drawing unless, actually, I don't think this is right. You can write the game however you want, but I don't think the dealer ever draws again. At least that's not what I see in this version of the game, which I think is a correct version. In Philander Chase's game, right? So when we do a new game, there's a hidden card and we can hit. We're at a 14. Yeah, the dealer doesn't. So I should actually take that out. The dealer doesn't have a strategy. Now, if there was other players, you could make this multiplayer and add more players that are computer players. Because oftentimes, usually when you play blackjack, you play with not just the dealer, but lots of other people. And you could do that pretty easily, because you could make as many hands as you want. In fact, you could have a list of hands, right? And so you could have like 10 players, perhaps. I don't know how many players typically play in blackjack, but you can have more than 2 players. More than 1 player. Okay, so that's the quick deal, right? I give you an example of the game that you can play. Here's the link. I talk about the rules. I give you the starting point and talk about it. And then here, although actually I don't like this, I think I may rewrite the program and give a different example of the code. But what you need to do is to start to look at this and think of questions and start to play around with it, right? Because this is your opportunity because this is due in a week, right? And so you've got to use classes. I've given you a lot, and you're going to move forward from there. Now, what we're doing this is important. I didn't tell the other classes either. For Monday, not Monday, next Tuesday, we're going to start learning a different language, a language called C++. And there's a different textbook for that. And you have to register for the new textbook, and you have to register for the new REPL class because it's a different language. And so if you go back up to the top, there's Kenyon CPP F20. You have to register for that textbook and then start to read it and do the problems in there. That's just a different textbook. That doesn't go anywhere. And so, actually, let me open this in a new link. So when you go into Runestone, once you have, you'll have two different books, and you're going to start reading out of this book. So you're going to need to register for it. This is C++ for Python programmers. Okay, and so you're going to see when in the text, sorry, when you see the reading being CPP, that means you need to read out of that new textbook. Then we see new REPL problems. I guess I'm done with this. So let me name this something different. Class to employee. Okay, so it turns out that there's another class that you can register for. Actually, student. So what you're going to do is you're going to go in and you're going to enroll in a new class. And the new class is Intro C, where is it? Well, I'm not enrolled in it because I'm, I don't remember how you enroll. How do you enroll in one if you're already in? Guess what we do, it's a good question. Okay, so if we go back to the REPL, I wonder if it's documented in here. I want to make sure we can get into here. You're going to be doing new REPLs, and they're going to be C++ REPLs, and that's what these are. I'm sorry, that's not what those are. That's what these are. REPL CPP 1 through 7, okay? And so, teacher, I know I can see it here. We have SCMP 118 C++, and that has a bunch of problems in it. And these are REPLs just like before. However, they're using C++ instead of using Python. What I'm trying to figure out, so anyway, are there any questions? What I'm trying to figure out is how you register for a new class. Let me see here. I've got these. Student. Seems like it should be under student. I'm assuming you only see the one class when you guys go under students. I can't see exactly what you see. Is that right? Actually, possibly what you do is this, now that I think about it. Sign up. Well, actually, Oh, this is a different account here, actually. Yeah. Now, how do you sign up for my class? I'm in here. This is the Python one. I've got to figure out how to add a class. Classrooms. Okay, well, class is over. I'm going to send out an email explaining how to do this. I apologize. I thought it was more obvious how you sign up for it. The class has been in existence for a long time, the C++ REPL, but I don't know how to tell you how to sign up for it. So I will see you guys later. Thanks for coming to class, and take care. Come to office hours now if you have questions.
Thank you.
Thank you.